Ratio test. Let the summation of an be a series with an greater than 0 for all n an element of the natural number. Suppose there exists a number c which is an element of the real number, satisfying 0 less than c less than 1, that is c is between 0 and 1, and k is an element of the natural number, such that the limit as n tends to infinity of the absolute value of an plus 1 over an is less or equals to c for all n greater than k, and the series converges. But suppose there exists k which is an element of the natural number such that the limit as n tends to infinity of the absolute value of an plus 1 over an is greater than 1 for all n greater or equals to k, then the series diverges. So there's a ratio test. When these conditions occur, the limit is between 0 and 1, the series is said to converge, but when the limit is greater than 1, then the series is said to diverge. Now let's take some examples. Example 1. Show by ratio test that the series, the summation from n equals to 1 to infinity of n bracket 2 over t raised to the power n is convergent. So we're going to show by ratio test that this series converges. So the solution. To start up with, we need to find an. We also need to find an plus 1. So the summation of an is equals to the summation from n equals to 1 to infinity of n into 2 over 3 raised to the power n. And this implies that an will be n into 2 over 3 all raised to the power n. So our an is equals to n into 2 over 3 all raised to the power of n. So then the entire of this expression is a sequence, that is the an. We need to find an plus 1. For an plus 1, it's quite easy. Anywhere there's n in the sequence an, we just need to add n plus 1. We need to substitute n plus 1 for n. So there's n here, that n will become n plus 1 all over 2 over 3 raised to power this n here becomes n plus 1. We're going to find the limit as n tends to infinity of an plus 1 all over an, of course the absolute value. So this is the limit we are looking for. Okay, the limit as n tends to infinity of an plus 1 all over an. Now this will be equals to the limit as n tends to infinity of an plus 1. An plus 1 is n plus 1 into 2 over 3 n plus 1. And this is all over an. An is n into 2 over 3 all raised to power n. Now we're going to solve this expression down, and our final answer would determine whether or not it converges or diverges. Now let's go. Now this is equals to the limit as n tends to infinity of n plus 1. Now let's simplify this expression. This is 2 raised to power n plus 1 all over 3 raised to power n plus 1 divided by n into 2 raised to power n all over 3 raised to power n. So instead of this division sign here, let's make use of this one to make it easier for us. So this gives us the limit as n tends to infinity of n plus 1 to n plus 1 all over 3n plus 1. Now we can turn this division sign to multiplication times 3n all over n to n. And when you turn the division sign to multiplication, you need to take this denominator up and take the numerator down. Okay, so the next step, we need to simplify this further as n tends to infinity into n plus 1. Now this 2n plus 1 can be expressed as 2n times 2 using indices all over 3n times 3. Okay, this is times 3n, and this part is times n times 2n. Okay, it's getting simpler now. So this is equals to the limit as n tends to infinity. Obviously, some of the terms will cancel, like 2n, it cancel 2n, 3n cancel 3n. So we are left with 2 over 3 into n plus 1 all over n. So this is the expression we are left with. Here we have the limit as n tends to infinity of 2 over 3 into n plus 1 all over n. Now we can simplify this to 2 over 3, the limit of the absolute value of n plus 1 over n. Of course, 2 over 3 is a constant, so out. So this is what we had now as n tends to infinity. So at this point, we need to find the limit. Now, while finding the limit as n tends to infinity is quite easy. All we have to do is to divide the entire term with the highest power of n. Now, the highest power of n here is 1. 1, that's the highest power of n. We're going to divide all of this term with n raised to the power 1. So it becomes 2 over 3, the limit as n tends to infinity over n plus 1 over n all over n over n. The reason why we are dividing by n because n raised to the power 1 is the highest power. Assuming we have n raised to the power 3 here, we will divide all through with n raised to the power 3. So this gives us 2 over 3, the limit as n tends to infinity of n over n is 1 plus 1 over n all over 1. Now, this is equals to 2 over 3. We're going to substitute infinity in place of n because n is moving to infinity. All over 1 plus 1 over infinity all over 1. And this is equals to 2 over 3, 1 plus the limit as n tends to infinity of 1 over n. Now this expression here is give us 0 over 1. So this is equals to 2 over 3 into 1, and this is equals to 2 over 3. So the limit of this expression here is equals to 2 over 3. So hence we can write that the limit as n tends to infinity of an plus 1 all over an is equals to 2 over 3. 2 over 3, which is equals to 0.666. And this number is less than 1. Now recall that from the definition of ratio test, if the limit c is between 0 and 1, then the series converges. So simply because the limit, which is 0.666, is less than 1, then the series converges. And let's take another example. Example 2. Show by ratio test that the series summation from n equals to 1 to infinity of 2 raised to the power of n all over n squared diverges. Now I'm going to show that this series diverges. Okay, now we know that by ratio test we're given the series an. Now this series an over here is equals to the summation from n equals to 1 to infinity of 2n over n squared. Now an is equals to 2n over n squared. Hence an plus 1. We're going to substitute n plus 1 in place of n. So give us 2n plus 1 all over n plus 1 square equals to 2n plus 1. That is n plus 1 square. Okay, let me simplify it somewhere else. We have n plus 1 all square. This is equals to n plus 1 into n plus 1. Give us n into n plus 1 into n plus 1. And this gives us n squared plus n plus 1, which is equals to n squared plus 2n plus 1. So when we simplify this, we have n squared plus 2n plus 1. Now let's go back. So this is equals to n squared plus 2n plus 1. Okay. So we have an, which is sequence, and an plus 1. We have them. Now we need to find the limit as n tends to infinity of an plus 1 all over an. Now this will give us the limit as n tends to infinity of an plus 1, all of this, so which is 2n plus 1 all over n squared plus 2n plus 1. Now this division sign here, you can just use it here, divided by an. An is this expression here, which is 2n all over n squared. So this gives us the limit as n tends to infinity of 2n plus 1 all over n squared plus 2n plus 1 times. Now the expression we have above, we are going to take the numerator down and the denominator up, turns the sign to times. So we're going to have times n squared over 2 raised to the power n. Let's try to simplify this expression. It gives us the limit of the absolute value of 2 raised to the power n times 2. If we simplify this, we have this. This is 2 raised to the power n. This is 2 times n squared all over bracket n squared plus 2n plus 1 times 2 raised to the power n. Obviously from here some terms we cancel. 2 raised to the power n cancel 2 raised to the power n. So we are left with 2n squared all over n squared plus 2n plus 1. Okay, now this gives us 2 into the limit of n to infinity of n squared all over n squared plus 2n plus 1. Okay, so at this point we are going to find the limit by dividing all the terms here with the highest power of n. Now this n, the power is 2, this power is 2, the power of this n is 1. So what is the highest power of n? The highest power of n is 2. 2 is the highest power of n. So I'm going to divide each of these terms with the highest power of n, which is n raised to the power 2. So it gives us 2, the limit as n tends to infinity of n squared over n squared all over n squared over n squared plus 2n over n squared plus 1 over n squared. So we have 2 the limit as n tends to infinity of n squared over n squared is 1 all over this is 1 plus 2 over n plus 1 over n squared. Now we can put our infinity in. So we have 2 the limit as n tends to infinity of 1 over 1 plus 2 over n plus 1 over n squared. So this was the last equation that we have. Now if we simplify this further, we'll have 2. Now let's put our infinity in. Becomes 1 over 1 plus 2 over infinity plus 1 over infinity square. Now this is equal to 2 into 1 over 1 plus, as long as infinity is the denominator and there's a number at the top, is 0. This is also 0. So this gives us 2 into 1 over 1, and this gives us 2. Hence, the limit as n tends to infinity of an plus 1 over an is equals to 2. And since 2 is greater than 1, from the definition of ratio tests, since 2 is greater than 1, if the limit is greater than 1, then the series diverges. So we can conclude that the series diverges. If you want to learn more about ratio tests, if you have any questions, you can message me directly on WhatsApp. Meanwhile, subscribe to this channel, like and share this video. Bye.